Business Finance, Chapter 12. One quick thing, if you look, there will be a Chapter 13 assignment next week, but no assignments for Chapter 14 and Chapter 15. And, it gets out of the quantitative stuff, and I think even your Chapter 13, I'm not sure that there's a lot of quantitative in there. Now, I'll probably run through some quick PowerPoints on those chapters, talk a little bit about finance in general, and then there's a few bigger issues I guess that we talk about when we get to there, but you will have quizzes, but hopefully that will give you guys also a little more time to work on your final paper, and I would like you to devote some time to that, and even if that means some back and forth between you and I, talking about your company and where you're going with your paper, that would be wonderful. As I've said before, that is truly what I enjoy doing anyways. So let's talk about Chapter 12's assignment. You guys have these 1 and 3 and 6 and 8 and 10, 11, 13, 17, 20, 25. Let's go take a look at some that are similar. So I did number 2, which is, I think, like your guys' 1 and 3 actually. So it should give you a pretty good idea. And then set them up, take the time to set these up. And I think that it will help you, this is what a financial statement looks like, or an income statement looks like, and reconciliation of cash, or I'm sorry, not an income statement, cash flow statement can look like this, okay, a basic one. And get used to kind of looking at these things and understanding them. That's really kind of the goal of the class. So first, for question 2, we have assume a corporation has earnings before depreciation and taxes of $100,000. So earnings before, actually I've got earnings before interest, taxes, depreciation, and amortization. That's a common term that they use as EBITDA. When you watch the financial channels, our problem doesn't really necessarily have those in it, but I just use the term because. So 100,000, and then it says I have depreciation of 40,000, and I'm in the 40% tax bracket. Well, how does that depreciation then affect my final income? Okay, and here's the thing. If I made $100,000 and I paid 40% taxes on that, I'd pay $40,000 and I would have a net income of only $60,000, right? Okay, but because I depreciate equipment, machinery, that I've purchased, it reduces my taxable income, and thus should save me some tax dollars, and it does. And this is how you set that up to take a look at it. So 100,000 and 40,000 in depreciation, those are given for me. And so my earnings before taxes, just abbreviated it, is 60,000. The 100,000, this is equal to my 100,000 minus my 40,000 in depreciation. So my earnings before taxes, and I calculate my taxes based on that 60,000. Okay, so my taxes at 40%, I simply put this as equal to 0.4, or 40% times that earnings before taxes. So my taxes are $24,000. And so my earnings after taxes then is simply my earnings before taxes minus my taxes. Was that minus that 36,000. But now a sleight of hand, okay, my depreciation is not an actual cash expense, okay, and so in terms of cash flow then, because it's not a cash expense, I don't have to write a check out for it. So in terms of cash flow, I add that back in just to see what my actual cash flow was. So all this is equal to my earnings after taxes, adding back in my depreciation, which I can get from here, or I could have got it from up there. And so I have a cash flow of $76,000. And again, if I'd had to pay taxes on the full 100,000, my cash flow would have just been 60,000 in that case. Okay, so that's what we want to look at there. Set your problems up the same, and you shouldn't have any difficulty. So we jump ahead to number 7, which is like, let's see, what do you have? 6 and 8. So it's a lot like your 6 and 8. And so 7 says, assume a $40,000 investment in the following cash flows for two alternatives. Which of the alternatives would you select under the payback method? And the payback method simply, it's a very simple method of taking a look. We often say that if we make an investment in something, how long will it take to pay back that investment? And that's all we're looking at here. It's a very uncomplicated way, but it's a simple, back of the napkin type of way to take a look at an investment like that. So I put down, and again, I like to set things up so I can look at them. And I got a $40,000 investment here, okay? And here's my cash flows for my project X, or product X. Okay, is 6,000, 8,000, and those are given to me in my product Y. Okay, my investment's the same, right? Okay, and all I did here then was took each year. Okay, if I invest 40,000, and in the first year I get a $6,000 cash flow, right? I've reduced my investment, I guess would be one way to look at it, to 34. Next year I get 8,000, and so, this is equal to this plus this. Okay, but then this one I have to change a little bit, because this one then is equal to my last year's plus my new income, right, or cash flow. Okay, now actually I can copy this one down the rest of the way, and it should stay. Yep. Okay. And so here we go. It took me 4 years is the answer for product X. It's 4 years. Okay. Product Y, on the other hand, I took a look at that, and so I got 40, and I had 15,000, so it's simply equal to my 40,000 plus my cash flow for that first year. And then the second year I got 20,000, so it's equal to my 25,000 that I still had plus my 20,000 there. Okay, and then actually that one I can drag down. Okay, and so this one just took me 2 years, 3 years, but not quite 2.5. Would that be accurate to say that just took 2.5 years? Okay, because this other I got 10,000 coming the next year, and it'd just be another half a year, so that'd be 2.5 years. So under the payback method, this one's the best, right? Yeah, but this one's got other income, so there might be other things that would influence my decision. And so again, the payback method's a down and dirty way to look at it, or back of the napkin. Okay, we have to, when we get to number 8, and I used different numbers here, but it's asking you to calculate the actual payback. Okay, and if you saw in 7, this 4 years, this was easy because this 4th year it equaled 0. But here, okay, what do I do? Okay, how do I actually calculate that? In this case, I could look at it and say, well, I'm minus 5,000 still. I got 10,000 next year, so that's going to be a half a year. And so it was pretty easy. It was pretty easy for me to say that that's going to be 2.5 years. But your guys' isn't that easy. If you look at number, what do you guys got, 9? No, you guys have 8 actually. Okay, so if you look at number 8, it says assume a $90,000 investment in the following cash flows for two alternatives. And there they are. Okay, so calculate the actual payback for investments A and B. And so the answer that we want is going to be a little bit more complicated than just 3 years or 4 years, because they're not even amounts. And I used different numbers here. I think I kind of used the numbers from 7, yeah, but I changed the amount of the investment to 37.5, so it doesn't matter. Okay, 37.5, and I set this one up just a little bit different so that these things would be right next to each other, kind of. Okay, maybe make it a little bit easier. And so my investment's 37.5, but my math is still basically the same here, right? This one's equal to this plus my first year's cash flow. Okay, then this one, I got to do 2 of these, is equal to my, what I have left, I guess would be one way to look at it, plus my second year's cash flow. Okay, from that point on, then I can drag it. Okay, I can't drag the first one because it always going to want to reference that first deal. So there we go. Okay, so here now, okay, I've paid back some, I've paid back some more, I've paid back some more, but I still got 14,500, and I'm going to get 17,000 in income. So really, all I'm saying is that if this comes in fairly consistently through the year, and that's what we would assume, I guess. You know, how big a part of the year? It's not going to take a full year, right? Because I've got 17,000 I'm projecting in income, and I only have 14.5 left for my payback. So it's not going to take a full year. Well, what percent of a year, or what decimal, or what fraction of the year would be the right way to say that, would it take? And so I did that calculation down here, and really all it is taking this number then divided by this number, because that gives you the fraction, right? And since this number is a negative, I just simply did it this way. If I start my formula with a negative, you could do equals negative, but I think I can just use the negative divided by that. And that turned it into a positive, and so it said 85 hundredths, right, of the year is what it would take. And then I know I got 1, 2, 3 that are negatives here. Okay, so I got 3. I just brought that down, and then this is simply equal to, you know, this plus my, and I obviously changed the decimals. Oops, I could make the decimals bigger if I wanted, but I wouldn't have to. Okay, and the same thing here, and I changed it on the other one. You know, it was obviously a half a year, so this one's going to be a little bit different. I don't know why I have 2.5 years in there. I don't know why I have 4 years there either. I think that was from the prior problem. So I've done the calculation here, okay, and so my calculation then is simply equal to this one divided by this one, which is, oops, and I should have done a negative, right? Equals a negative. So I get a positive. Let's try it. Let's start all over. Let's just put in that minus the 2,500 divided by the 10,000. There we go. Golly. Okay, and then I got 1, 2. So 2 in there. And this is simply equal to this one plus this one. So 2.25 years is my actual payback. Okay. And that's going to be important. Your guys' may be closer, and so that could be important then for making your decision actually on the payback method. All right, jumping forward to 9. 9 says this. Do you guys have number 9? Nope. You guys have 10, so it's probably like 10. So number 9 says, the short line railroad is considering a $140,000 investment in either of two companies. The cash flows are as follows. Okay, 85, 25, 30, 10, 10, 10, 10, 10, and 30, 25, 85, so just backwards, right? 10, 10, 10, 10, 10, 10, 10. Okay, so I plugged in the cash flows. I got 10 years, and I just plugged them in as they were given, and I had $140,000. And I went ahead and did the math over here. I kind of put these in different colors so you could see it, and certainly you could flop these around. That might be easier. I'm not sure I did this in the easiest fashion for you guys to understand. I could move this one over here, but anyhow, do the math right, and you'll see, you know, because the cash flows, even though they're a little bit reversed after 3 years, you know, both of them I would have it paid back. But why is that a little bit confusing, or is it misleading? Okay, well, the answer is simply, right, I'm getting more cash flow here sooner, right? I'm getting 85 grand this first year, okay, and this first year I'm only getting 30, okay, and so that can create more opportunities. I got 55,000 more dollars here that I can be investing or doing something with than I do here, okay, and in real terms it means this, and this is what we're going to be working on now. And so let's take the net present value of these cash flows and compare them, right? And so I've done that. Oops, I'm gonna cancel, hit delete, and start over. So let's calculate the net present value. That's a financial, and it's under the ends. It is just NPV. Okay, and we haven't done NPV, but NPV is one of the easiest formulas to use in Excel because you got a rate, and they've given us a cost of capital as 10%. I'm sorry, they didn't. I just assumed a cost of capital of 10% here because it's not asking this in the problem, but I just kind of wanted to run through it quick because it'll be like future problems. So I've got a 10% rate. I just plug that in, and my value 1 is just this cash flow. And all I have to do is left click and hold down, drag until I got all those covered. Tells me what my answer is. Hit my enter. And so the net present value of this cash flow is $157,000, and my investment was $140,000. So after with a 10% cost of capital, okay, so I'm applying that 10% basically to these, and so even so, after that 10 years, then my net present value, if I'm comparing that, and this is a very good thing to compare, I'm comparing the net present value of these cash flows to my investment, and it exceeds it. So that's a good thing, and it exceeds it by $17,000. This is simply equal to, this minus, but because my top one's a negative, I'm going to hit the plus. Got that. Okay. So it's 17,000 better on a net present value. Okay, that's an apples to apples comparison. This is net present value compared to that. When I change it up and I don't get as much that first year, my net present value is only 148, and the difference 8,000. So clearly, alternative here, the electric works is the superior alternative if I were figuring that out, even though the payback is the same. And so that's also showing you that payback isn't 100% certainly. Okay, so then we jump ahead to 12, and I think you guys have 11 and 13, and so 12 is going to fit in there. And 12 says this: King's Department Store is contemplating the purchase of a new machine at a cost of $22,802. So I got that up there. The machine will provide $3,500 per year in cash flow for 9 years. King's has a cost of capital of 10%. Using the internal rate of return method, evaluate this product and indicate whether it should be undertaken. Okay, and I did this 2 ways because, again, I wanted to show you what's coming up, and it might be even in your problem. So I just put in the stuff that's given to me. Here's my investment, right? Is this $22,802? Okay, here's my cash flow. Boom, $3,500 a year for 9 years, and I can put that in like this. It's a little easier. I can just do that and drag her down. Okay, now internal rate of return is probably one of the easiest. It's even easier than the net present value that we just did. Okay, and it's IRR, internal rate of return. So I come up and I don't want to put it there. I'm sorry, I got to cancel. I want it to be here, and I'm just going to delete that. So I come up and I click that, and it's under financial, and it's IRR. So it'd be alphabetically, there it is, returns the internal rate of return for a series of cash flows. Okay, there it is. All I have to do then, it's asking me for the value. So I click on the investment, and I drag it down, left click, and I drag this thing down to incorporate the cash flows. Take my finger off and hit my enter key, and voila. Okay, I would have a 7% internal rate of return on these cash flows. Now, my cost of capital is 10%, so the logical question is that a good investment? No, I'm only getting 7% here, and my cost of capital is 10%. I don't really want to do that. Okay, I don't want to do that at all. Let's say it that way. Okay, and to kind of highlight that, okay, or to corroborate that, I also did the net present value calculation on this. Again, you guys might have to do some net present values, and this is the second easiest one. I wonder why they save these easy ones for last. Okay, I'm going to go to most recently used because I got net present value right there now. I got my rate. I'm going to use my cost of capital here, okay, and then I got my values, which is, oops, I'm sorry, I want to start here, left click and drag. Okay, I skipped the investment on this one. I skipped the investment. Okay, gives me my answer. And what this tells me, it confirms that my internal rate of return is less than my cost of capital, because it's saying that if I use this cost of capital in figuring these cash flows, I still would only come up with a net present value of $20,000, which is not equal to my investment. And so it would be a bad investment to do that. I'd want my net present value using my cost of capital to at least be equal. That would be a break even, but probably to make money. Okay? And it's not. And so this would not be a good investment. Onward we go. We jump all the way to number 18. The Pan American Bottling Company is considering the purchase of a new machine that would increase the speed of bottling and save money. The net cost of this machine is $60,000. The annual cash flows have the following projections, and we have those listed there. Okay. If the cost of capital is 13%, what's the net present value of a new machine, and what is the internal rate of return? So this one has both of these. Okay, it's requesting both of them like we showed before, and should the project be accepted. So again, I just input my amount, $60,000 investment. I put my cost of capital over here, just a separate slot there, so I have it for reference. And I got my cash flows. My cash flows are the same, so I set them up once and then I just copy them over and away we go, right? And now I have two calculations. One's the net present value using my cost of capital. And again, that's, most recently used net present value. Again, rate is my cost of capital. My values are simply just the cash flows again. Don't include the investment. That would goof it up a little bit. Okay. And then I also went ahead and just took that one step further and said it's equal to my net present value minus, but I got to use the plus because that's a negative. So my net present value of my cash flows using a 13% cost of capital, so that's my, kind of my rate of return, minimum rate of return that I want to receive is 74, and the net when I take out my investment would be 14. So that's a good investment. Okay. Now, if you didn't look at column C, what I could tell you absolutely, and this is what you need to know kind of in both cases, either way, going from net present value to IRR or vice versa. This means then, because this is positive, that my IRR is going to exceed my cost of capital. It has to, right? Because my return is going to exceed what my investment is, figuring it on a net present value basis. So I know that my IRR is going to exceed my cost of capital. Okay, and again, I got the simplest calculation here. IRR, boom. I do capture the investment here along with the cash flows. Hit enter, 23.77. Okay. So should I make this investment? Absolutely. It's going to exceed my cost of capital substantially. I would make that investment every day if I could. All right. Onward, 20. I don't know why I changed the colors on that, but it doesn't really matter. So I think you guys have 20, so hopefully I changed the numbers on this a little bit. Otherwise, I'm just giving away the answer. Oh, no. No, don't do that. You guys have 20? Wow. And I'm providing you the answer. I guess I'm going to stop there and not give you the answer, and instead we'll jump over here and we'll come back maybe and set that one up on a different sheet. Let's do that because we'll do some different numbers here. Let's expand this thing. I should have expanded some of the other ones. I don't know. But let's use some different numbers and set it up. So, okay, Turner Video will invest $76,344 in a project. The firm's cost of capital is 10%, and the investment will provide the following inflows. The internal rate of return is 11%, so it's giving us the internal rate of return in this case. So let's do this. Let's set it up and say I've got, golly, I must have hit the cap lock or something. Okay. Let's say instead that my investment is going to be $50,000, and I need to make that a negative. Okay, Okay, and I'll say that my cash flows are, I just got to make some guesses at some of these. So 10,000, well, let's do years, 1, 2, and hopefully you guys know that if you do that, then you can just drag it down, 3, 4, 5. So I'm going to say my first one's 10 grand. My second one's about 11,000, and my third year is about 14,000, and my fourth year is about 20,000, and my fifth year is maybe about 24,000. Oops. 24,000. Okay, got her all set up. There we go. I'm happy. Put my little line below that. I know that my cost of capital is 10%, so I need to put that in here. We'll do that. I'm going to do that here, and I'm going to show you why here, I think, in a bit. But I'm going to put my 10% there, and then my internal rate of return I'm going to put there. Okay. I'm going to make those percentages just because. I'm going to do that. Okay. Now I'm also going to change one other thing here, and I'll show you what that is. So, okay, because we're doing a reinvestment assumption. Okay, and I'm going to go 5, 4, 3, 2, 1. What we're doing here, so you know, is we're saying that when we get cash flows like this, and we're doing an internal rate of return, we're doing net present value and those types of things, we don't know, or we're not assuming that that money's necessarily being reinvested in anything, okay? And yet, in real life, you would, okay? If you got a $10,000 cash flow here, okay, it comes in, it kind of offsets your investment, yeah, but that's $10,000 in your bank account that you have now that you're going to reinvest. And the difference is, it's asking in A and B is that which this one says this is my cost of capital. So what if we reinvest it with my cost of capital, or what if I reinvest it at my internal rate of return, or if I can invest it at the same rate that I got on, you know, this particular investment. Okay, and you calculate both. Okay, so how do you do that? Well, that gets to be a little bit more complicated, because what you got to do is calculate then the future value, because you're going to get this money and you're going to invest it, okay, and over the period of the 5 years, okay, and see what the future value of that is. Okay, so I do it like this. That's why I did the 5, 4, 3, 2, 1, because this one's going to have, you're going to be able to invest this for 5 years. You'll be able to invest this one for 4 years, for 3 years, for 2 years, and for 1 year. So let's do that. Let's go here and go future value, which I have. Okay. My rate, in this case, I'm using my 10%. Okay. My number of periods, and this is why I did this, is the 5. Payment I don't have. I have a present value. I'm going to go ahead and enter that in, I think, as a negative. Okay, type. Let's see. Returns the future value based on type is the value representing the timing of payment. Payment at the beginning of the period equals 1. Payment at the end of the period equals 0. Okay. Yeah. I got to see if I can remember which one I do here. I think it would be at the end. Okay. Oopsie. There you go. So what that's saying is that when I get this $10,000, if I reinvest it, okay, for 5 years till the end of the investment, I would have $16,000. Okay. Now I do want to do something, and I kind of screwed up there, right? This reference needs to stay the same. So my interest rate, which is D2, right? And so I should do this, and on my interest rate where it says D2, I should hit my F4 key. That puts the dollar signs in there, right? Which is going to keep that reference the same. This one's going to move, and this one's going to move. Okay, and my type will stay the same, and then I should be able to just copy this. Ooh, isn't that weird? I wonder why that one would be the exact same dollar amount. That's just got to be a strange coincidence. Wow, that is a strange coincidence that that would be the same dollar amount. Whew, I'm sorry, that just intrigued me. I gotta look at the decimals even on it and see if they're the same. Wow, did I do something wrong? That is just astounding that those things would be the exact same. Oh, because the 10%, yeah, that would make sense because after 1 year, this is going to be 10% bigger, and so the dollar amounts would be the same. So, okay, I got it. Okay, so there we go. There's my, if I'm reinvesting those things, okay, instead of these cash flows, it should equal a total here. So I'll sum these. I just want that one. I don't want my interest rate up there, and there we go. Okay, and my total here, you know, if I sum these without, all right, 79,000. So I get a much better, much higher total there. Now, the 11% would be the same thing, right? It should be bigger. It should end up being a bigger number. So I just have to do the same thing. My future value, my rate is my 11%, but hit my F4 key. Okay, my number of periods is this one. My present value, enter that as negative, is this one. And my type, and again, I believe that that's a 1. It's, oh, shoot. No. That should be a 0 because my payment's going to come at the end of the year. I am sorry. That should be a 0. I'll have to go back and fix that on the other one. Okay. Okay, and this one I can just copy over because it's just going to sum those. Now I got to go back and fix this and make that a 0. I'm sorry, because I wouldn't get that first one until the end of that year, right? We didn't change it. It didn't care. I'll be darned. It didn't care. Be that way. Okay, and as you would expect, this one's a little bit bigger. I have to go back and figure out why it didn't care. It should care, I would think, but maybe not on the future value. So that's how that's a little bit complicated there for number 20. Okay, and obviously then this one returns you a little bit better amount. Okay, which one's more? Which one should you use? You know, generally speaking, the answer is going to be the more conservative one, right? It's going to be the more conservative one that you would get. And keep in mind, you might, you know, your best alternative might be a CD at 2% instead of the 10% where you might do those same types of calculations, okay? And so your reinvestment rate might not even be your cost of capital. So, okay, I took enough time on that. Let's go to 25, your last one, set this thing up. This one gets to be a little bit complicated as well. It says this. It says Telstar Communications is going to purchase an asset for $380,000. I think you guys have what, 20? Yeah, you guys have 25. So, dang. Well, I just show you how to set this one up, and I don't give you the answer. So, for the next 4 years in earnings before depreciation, and it's going to produce $180,000 per year in EBITDA. Okay. Per year for the next 4 years in earnings before depreciation and taxes. The asset's going to be depreciated using the 3 years Macker's depreciation schedule in table 1212. This represents 4 years of depreciation based on the half-year convention. Ugh. Yeah, that tax stuff is always kind of confusing. Anyhow, the firm is in a 35% tax bracket. Fill in the following schedule for the next 4 years. Well, we did this on that first one. Okay, it's no different other than we're just going to calculate really what the depreciation is, right? Don't I have this set up exactly the same way as that first one? And so we'll ultimately get down here and figure out what our cash flow is. Okay, and I put in here that I believe it's page 401 is where I get the Mackers. Okay. Because depreciation is not always straight line. The government, the Congress loves to mess around with the depreciation schedules. So I've got the 3 years Mackers, right? And it gives me 4 years then, why they call it the 3 years Mackers. It sounds like a government thing, you know. So it basically gives you 4 years there that you're going to depreciate that, and it gives you the amount, okay? And so the depreciation, keep in mind, is based on the purchase price. The biggest error I see made in this problem is that people make the depreciation based on this. The depreciation is based on the purchase price, right? And so for the first year, it tells me that my 3 years MACRS is 0.333, or 1/3 basically of my purchase price. So I'm going to just simply, this is equal to 0.333 times my purchase price up there. Okay, so there's my depreciation. Here was my EBITDA, my depreciation. So my earnings before taxes was equal to, or is equal to, this minus my depreciation. Okay, and then again, I've got the rest of it set up. I just need to calculate then what my taxes are at 35%. You know, what's that going to be? 15, 16, 17,500, something like that in taxes. I'll have my earnings after taxes, and then I get to add back in my depreciation, which I just set up automatically, is equal to C4, and you could just do that along there. Wonderful. Okay, so the next year then, the depreciation is 0.445, so it equals 0.445 times, right, my purchase price, times my purchase price. Something got goofed up. Oh, I didn't hit the equals. Right, I got to hit my equal sign. I'm sorry. Equals 0.445 times my purchase price. And there I got my depreciation then for the second year. It's just too big. And that's good. I didn't really want to show you that anyhow, although it does show it down there. Okay. So we'll go back and delete that. Okay, so then you just figure out that cash flow for all 4 years. Again, it shouldn't be any more complicated than the first one that we did. It just seems a little bit bigger, and you got to calculate this depreciation. But other than that, it should be relatively easy then to calculate what your cash flow is going to be. So that's it. I took enough time. I took a long time explaining that one, but it is a little bit complicated, and so that's why. I hope you guys have a good week. I'll be back a little bit later and talk to you a little bit about Project 2. We'll start looking at some companies and some of the things I want you guys to look for in the financials. So thanks, and talk to you soon.